Hey everyone, Brian Beeler. Welcome to the podcast. Today we've got Taylor Monig from TMGcore. And Taylor, at a quick level, what's TMGcore all about?
Yes, at a high level, TMGcore we like to call the home of immersion. So we produce both single phase and two phase immersion cooling tanks for data centers and blockchain applications.
Okay, so a perfect summary, and I'm glad you said that. We ran into you guys at Dell Tech World a couple weeks back out in Vegas. You had I would describe it as an aggressive booth setup. You had a bunch of different tanks, and I want to get into all of those. And you had liquid in them, and many of them were running, which was really cool. And to be fair, some of your competitors there had cardboard servers in their display. So I appreciate you guys, actually going through the steps. It must be a massive pain in the butt to haul that stuff out to Vegas and set it up and all the liquid. And I want to get into all of that. Um, but you guys are in immersion. Let's take one step back and set the tone for what's going on in alternative cooling for servers. Because we did post, as you know, some videos on social. We were talking about what you guys were doing. And the reaction was sort of polarizing, right? We had a lot of people that loved it, thought it was super cool, super green, really efficient, really smart. And then a lot of other people that I'm sure you run into on the enterprise side all the time that are a little more traditional, not to disparage them, but a little more traditional and not quite ready to embrace what's going on with liquid cooling. But just what are the options out there? Either, obviously you guys are full immersion, but what are the other options out there when we think about liquid cooling in general to help set the tone?
Yeah, absolutely. So, I mean, I think the first place to start is actually like a 50-50 blend with a rear door heat exchanger. Technically, I'd bring that into the immersion cooling space as, it does involve liquid. Moving from there, you have liquid on chip, which is where you're going to run either water or a Novec type based fluid directly to the chip. And that's liquid on chip. And then you move into open bath immersion, where you have both single phase, which is mostly synthetic oils that are used in today's marketplace, and then you have two phase fluids, which is fluorinated, hydrocarbons such as 3M's FC72 or Solvay's HT55. So you'd start at rear door heat exchanger and work your way all the way up to two-phase immersion cooling, which, in my opinion, is technically the newest and most advanced form of cooling for the data center.
Okay, yeah, I think you're right. And I had actually, I've seen the liquid cooling doors a couple times, but that one had even escaped me. I went straight to closed loop, on the either in a system to do GPUs most likely, or with a CDU that runs either at rack or multi-rack scale to move some liquid around. Um, but the door, though, is maybe the easiest way if somebody wants to kind of limp into liquid. Is that the I think it probably is the easiest way to consume some of this technology, right?
So they're all going to have basically the same complications, right? If you're coming from an air-cooled facility that has no water running through it, you're going to have to run supply and return lines for no matter what. If it's a rear door heat exchanger or a two-phase, immersion system, that part's going to be about the same on the infrastructure. There's a lot of actual drawbacks to having the individual, liquid to chip in some of those options. But as far as server modifications, yeah, sure. I think the rear door heat exchanger might be the easiest way for someone to get into that space, as in you just run the water return and feed lines and everything, and then you would just run the servers as normal. So yeah, I would agree. I guess that would be the easiest first step for someone that's looking to increase density within their data center.
Okay, and then when you're talking about liquid on chip, probably the easiest way to visualize that is PC gamers, right, that are throwing liquid cooling onto their CPU and in some cases their GPU in a little closed loop system within the box, right? I mean, is there another way to help people kind of conceptualize what that means?
No, I think that's a perfect example, Brian. In the consumer gaming industry, it's becoming more and more popular for people to liquid cool both the CPUs and GPUs in order to get the kind of performance at home that they're looking for. And over the last couple years, people have tried to adapt that to the data center world, and are having some success doing so.
Well, yeah, and Lenovo's got in their SR670, they've got a little liquid plate for the GPUs, the socketed GPUs, combining it with fans and doing some other stuff. It's again, it's another bridge to help get people moved along in terms of the idea of, look, fundamentally, we're not going to get much further on air cooling, either because of power constraints. I mean, the fans are using a lot of power. We're spending a lot of money on cooling for data centers. That doesn't necessarily have to be done that way. And as we get into Gen 5 on PCIe and Gen 6 and the latest CPUs, I think we're getting closer to being exposed to this problem. HPC's been there, right? They have these very real challenges with operating GPUs around the clock and having to deal with the thermals. Mainstream enterprise is going to have this same problem because air cooled, I don't think, is going to get it done in another maybe 2 generations of server rotations. And what's your visibility into that?
No, I believe everything that you said, Brian, was very accurate. In the HPC world, for a number of years, we've been dealing with these heating issues. Specifically, I believe it started with GPUs, so I believe that statement was also accurate. Um, and if you were to look at Intel and AMD's roadmap, I think just to be a little bit more aggressive, I think within the next year, you're going to see more and more chips that need liquid immersion cooling or liquid to chip. And to reinforce that, I think we've noticed that some of the major server designers, when we went to this latest round of GPU, got a lot less GPUs, but had to add more U's in order to cool them. So we're already seeing that paradigm shift. But for me specifically, it's really about the efficiency. And what you spoke to with air is really the driver for me. We might be able to do it with air for a little bit longer, but at what point are we just wasting a whole lot of energy in order to get that done instead of adapting to a new technology that's already been proven all across the world and is ready to go? That's really what does it for me on liquid immersion is the performance, but also being able to tie in those efficiencies.
Well, the efficiencies are real. I mean, even the challenge that you talked about with air cooling, how most of these servers are going to be at least 5U that are GPU dense instead of 4 or less. I mean, you could flatten the thing out and do it in 1 with the socketed GPUs anyway, if you were able to be super efficient with the way you were cooling them. But most designs don't accommodate that. The big designs let them have bigger fans, which they need, and to move more air, and they're maybe a little more efficient than teeny fans. But I mean, it's kind of splitting hairs because we still have the problem in a lot of cases where the rack only has so much power. So we're not, in the US anyway, we're not so constrained by rack space because you can't really put, you can't go 42 or 48U of GPU servers in most racks because there's just not enough power to the rack to supply it. But on the other side, I mean, there's places like Europe where energy expenses are very, very high and not slowing down anytime soon. So, they've got an efficiency challenge there, a cost challenge. And a lot of orgs that have green initiatives now, they're all hit with these things, right? Whether it's energy consumption or just generally being efficient and footprint and all sorts of other challenges. So again, liquid in all these forms helps address some of those problems in different ways. But you guys being full immersion now, so let's dive into that. How do you differentiate, or how does immersion differentiate from these other technologies in terms of where the key advantages are?
Yeah, and if we could, I really want to highlight what you just said about GPUs and the space, right? So right now with Air, you talked about 4Us, maybe 4 GPUs of the latest gen, right? Last year we designed a server with 2 Intel processors and 16 GPUs in a 1U box. So a lot of the times right now, people's mindset is trying to wrap the current gen servers and put them in immersion and try and compare open bath immersion to these other technologies in which the servers have been designed for. But they never really take that next step to think, oh, well, what if I design this a little bit differently and then put it into an open bath immersion server? What would my performance and what would my space constraints be, then? So a lot of the times they like to make generally unfair comparisons between the technology, utilizing servers that aren't designed for what we do. And then when we design servers to, take advantage of that, the performance is quite extreme. I don't believe there's any other technology that's going to allow you to put 16 GPUs in a 1U space and run them at, full performance. So that's something that I definitely wanted to talk a little bit more about since you brought it up earlier in the conversation.
Yeah, well, you're right. So I think there's 2 things at play here, right? Because you can take standard off the shelf, we saw you at Dell, but it doesn't matter, and dunk them into your sort of sideways racks on the floor and load them up that way. But you guys also do some server design yourselves. I've seen those. I mean, they look like blades. They're bigger, but they're a little skinny, servers, and you're doing what's the socketed GPUs, V100s or A100s or something on there across the board, right?
Yeah, so the last design I just spoke about was the V100
Right.
generation
Okay.
GPUs. We have, a number of servers that we designed. One that we were highlighted with Intel was our Walker Pass server, which has the 12 nodes within the 1U box as well, basically, tripling the density of a normal air-cooled unit. So yeah, we've done a lot of different server designs and a lot of different work to really show what the future of immersion cooling could possibly be. And to your point, right now we do make designs that take standard off-the-shelf servers and allow you to deploy them in an immersion environment. So that way we can, show people our technology, basically get their feet wet, no pun intended, right? Start to use the technology and get adjusted to it. And then, people start to look at, how can we design servers to really take advantage of this space.
So let's walk through some of this because you had a number of demos on the floor at Dell Tech World. I think if we start with this single phase, that's the easiest, progression to move people along in this concept. And I'll describe what I saw, and then you can kind of correct me where I'm missing out, because I'm looking at this purely from a layman's perspective in terms of what you've got. But I said before the rack tipped over. So if you're trying to visualize this, in my mind, it's a 42U rack, I think, that's essentially on its side. So it's rectangle flat on the floor, and the servers are dropped in just like they would be as they were slotted in if it were a vertical rack in your data center. You've got an engineered fluid in there for cooling, and you're running all the cabling kind of runs around the sides or up to the top. You've got a PDU unit distributed across the top, and you can look down. I mean, it's open. You've got the servers there just doing their thing. I mean, that's from a visualization standpoint. What am I missing? I think I got most of it.
No, that's correct. I mean, just to get into the nitty gritty, right? It's a 48U rack, not a 42U.
48. Okay.
Yeah, just to kind of clarify details there. But yeah, it's a single phase fluid. It's a rectangular tank on its side. You would slot in servers just as you would in your air cooled environment. The difference being every single one of those, we remove all of the fans and change the BIOS, so you're not wasting energy on fan cooling per server, which really helps. And we're basically at a really layman's level, pumping cold or, in this case, technically warm oil into the bottom, letting the oil rise through the machines, carrying the heat with it. That oil runs over a waterfall into a weir system, and we pump it back through. It's a lot more technical on how we spread all the oil and keep everything even within the bath. But just to keep things simple, that's generally how it works. Cold in, hot off the top, and we just keep that rotating.
So tell me about thermal expenditure then, because obviously the servers are still making heat even in this engineered fluid bath that they're in. Where does the heat go?
Yeah, absolutely. So we're carrying that heat off the top of the tank out of that weir system. We're pumping that through a plate heat exchanger, which is on the backside of the unit.
Okay.
That plate heat exchanger has water running to it, and that water will run out depending on the environment and or the deployment situation to either a dry cooler, cooling tower, or a fluid cooler, just depending on what our customer would like to use in the environment that they're in. Technically, you could use a chiller as well, but we would really never recommend using that much energy.
Mm-hmm. So in the case that you're talking about, is there an opportunity for your customers to repatriate that heat and do something else with it? I mean, we hear these stories about the closed loop solutions at HPC data centers where they're at a university and they heat their pool with the energy from the data center. Can you do similar sorts of things with these types of systems?
Yeah, absolutely. What you're getting is hot water out of the exit side, and whatever you would like to do with that water is up to the customer. As long as you bring me water back in within our spec point, we're completely okay with that. So yeah, it's a good way to reuse that energy and also tell that green story.
Right. So heat the pool, maybe run a car wash out of the back of the the data center or something, right?
Some people use it for everything from growing plants to heat and pools. Just depends on what their business situation is.
Okay. So we load the servers in, we've pulled the fans because we don't need them. What about power supplies? They've got little fans on them. What do you do? Is there anything to be gained there by doing something different with the power supply?
Yeah, we disable those fans as well. From
Okay.
my opinion, every single one of those fans is a failure point. So not only are we saving you energy, but we're also making sure your server stays online.
And what do you know? Because you guys would know on fan power consumption Intel put out some data a couple weeks ago. They said it was about 4%. I think that's low. I think the fan electrical contribution is higher. We've seen some numbers where this next gen Sapphire and Gen 4 from AMD, it might even be closer to double digits in terms of impact on the electric used in the data center. Do you have any stats or even just some tangential numbers on that?
No, you're spot on. Anywhere from about 10 to 4% of the power, depending on the device, and also depending on the environment in which it's ran in, right? So if it's in a warmer data center, it's obviously going to have to pull those fans harder and have a higher utilization percentage. Depending on if it's in a cooler data center, it would be lower. But I think it's accurate to say within 10 to 4% of each server unit is typically fan power draw.
Okay. So we get rid of those, so a lot of efficiency, modify the BIOS so that we're not overspending on other performance modes or whatever in the system, which makes sense. Anything else, or are you the lids stay on? I mean, is there anything else, other physical modifications that have to happen?
No, in single phase, we actually reuse the air-cooled heatsink in almost every single application that is different in two phase, so we can cover that. But generally, just removing the fans, changing the BIOS. We have some customers that take the lid off. We have some customers that leave the lid on, just depending on what server, what brand, all those types of different variables. That's generally it, Brian. It's not a lot to take a server from air-cooled to immersion ready.
No, the vendors probably, will they sell you a server without fans? I mean, do they have that modality in their ordering system?
No, we prepare all of the servers here as immersion ready servers. We will be working with OEMs to provide immersion ready servers. As you know, there's a very large market for it, and it continues to develop, and the OEMs have been pretty responsive to that market. As you saw, we had a bunch of Dell servers within our tank, and we're publicly engaged with them at the Dell conference and showing off TMGcore. So obviously they've leaned in heavy, but they're not the only ones.
Yeah, I mean, I think they're going to have to be getting creative in terms of how they bundle these things, right? And maybe it's just a channel thing direct for you guys, but just like, why take the labor and expense of putting the fans in there and shipping them and all that other stuff? Doesn't make a lot of sense if it's going to immediately go get wet anyway, right?
Well, yeah, and I mean, when it really comes down to telling the green story and being efficient as a data center operator, right? Every single one of those fans contains plastic and a bearing and a motor and copper cabling, right? Every single thing that we can remove from the server is one less thing going into a landfill at the end of its life. So all the way down to that level, you're saving not only energy but also saving plastics, metals, connectors, all sorts of things.
Yeah, no, it makes a lot of sense. Okay, so that gets us in there. We're running power up to your PDUs, networking. Are you dumping the switches in these things too?
You can dump the switches in the single phase oil. We have switch mounts on the outside. So on the front of our units, you'll see the switch mounts. And as you said, we have the PDU rack system in the back. The reason why we built that is so that way, you can really get, up to 200 kW to your tank if you wanted. As you, stated earlier, it's so hard to run a full rack of GPU servers in a typical air server. Well, in an immersion an immersion tank, it's not. It's pretty standard. So we have a number of PDU positions up there, and then a number of network switch mounting options on the front. So that way our users can cable just like they would in air, operate just like they would in air. And the only difference is you're pulling that server vertically out of the bath instead of horizontally out of the rack.
And so then what does that mean for storage? Any implications there? You could do a storage array? I mean, I guess it's the same thing as a server, right?
No spinning disks. So
okay.
Yeah,
what about not even the air sealed, the helio sealed kind of ones?
In my recommendation, I would not. Everything leaks, so just depending on how long it's going to take to leak. So we recommend running solid state hard drives and anything that's going to make contact with the fluid. Also, storage arrays are not exactly energy intensive. So you probably wouldn't want to put your storage array inside of immersion. You really want to hold that for your, upper limit CPUs, the GPUs, things that are really producing heat. Those are the things that we recommend to our customers placing in baths.
Okay. So mostly the compute then is the way you're looking at it.
Yes, sir.
Okay. Now let's talk about serviceability, because that was one of the questions that came up quite a bit, and you obviously have an answer, but I don't know what it is. So when we have a component fail, an SSD or a DRAM or whatever, how do you do that? How do your customers handle that?
We have a gantry system hooks into the servers. It's an automated gantry. Just press a button, server gets pulled up, replace the component either on the gantry or on a table next to it, and then put it back in. I read through some of the comments on the TikTok video I'd posted and made me laugh. There's a lot of people under the assumption once it's in the oil, it's unfixable, it's unworkable, it's unretrievable. It's capable just like a typical air-cooled server. You'll go in and take your power plugs out, take your network plugs out, whether you're using Ethernet or InfiniBand or whatever you got going on, and you'll just pull the server up. The nice part is you have a lot less server events in the fluid. We've removed everything that's moving. We've removed all the spinning disks. We've replaced everything with solid state. And generally, we have a really low failure rate within the oil, and people don't need to service them nearly as much. But it's simply just pull it out with the gantry, service it just like you would any other air-cooled computer, and then put it back in.
All right. Well, you're loading kind of the rear down though. So with the power supplies and networking on the bottom, how does that work? Because you obviously can't reach in there with a big gloved arm and.
No, you don't need to do that. The way the cabling system's set up, you can run the power cable, plug it into the server, and bring the server down.
Okay.
So yeah, you're not.
So you have enough slack there to be able to manage that.
Oh, absolutely. Yeah, okay. Absolutely. Like when we build the systems, we've been designing systems for 4 years now. We've had a ton of experience with serviceability and how to generally just operate the servers, work with the servers, pull the servers, all those things. And we definitely incorporate all of those learnings, into our units. You're starting at TMGcore, which is our basic single phase operating. We have a fully robotic 2-phase system that will literally load servers for you. It's completely cableless as well.
Oh, nice. Okay. Well, yeah, I mean, it would make sense to have some sort of, your setup makes sense for some sort of mid-plane where you chunk the compute into and then they're exposed to, power and networking on the back end. I think, ultimately you could do some pretty neat things there to reduce parts and make the simplicity just a little bit more than the Dell solution or any OEM solution where you're working with their physical servers.
Well, we would love to have you out to the TMGcore facility and show you that. It's already been designed and done, and it's auto once more.
Perfect. Good. Yeah. You're in the facilities in Dallas. Is that where the HQ is?
Yeah, we're in Plano, Texas, like right outside of an area called Legacy West.
Perfect. Okay. Is it possible to partially remove a server and swap like a SSD in the front plane or something like that while it's running? Can we keep it up and do that?
I would not recommend in a single phase solution pulling the server for any amount of time and keeping it powered. If you need to do an event, we would recommend turning off that individual server, doing the switch, and then repowering the server. You do have oil basically containing a heat generating component with no fans or no airflow. Not something that I would personally recommend our users doing. Okay. We depower things, we service that, we bring it back on.
And so when you pull it out, it's a little drippy, right? So what's that mechanism to let it dry, for lack of a better word, if we're going to take it out and put it on a crash cart and do something else with it physically, like swap a NIC or something?
Yeah, for single phase, you just have to let it drip for a while. There's really no secret way around that. We have drip pans and trays that we use to contain the oil, do the service, put the oil back in. With 2-phase, by the time the server actually leaves the bath, it's completely dried, completely clean, and you don't need to do anything with it. You can just service it as a normal PC.
Okay. So for the single phase rack, it's 48U. It's on its side, so it must take up, 2.5 rack footprints? Is it because you lose some space there, right?
It's about 2 racks.
Okay. But you can mitigate that by being more efficient with what you put in the liquid, I would assume your argument would be then, right?
Yeah. I mean, you can obviously put up to 200 kW, within that constraint. So that'd be equal to having 2 100 kW racks, which technically, I've never seen before in air.
Okay. So who's doing this now? What types of customers? Obviously, HPC has been doing stuff like this for a while. We always see liquid solutions at Supercompute. In fact, this year in last year in St. Louis, I think at least a quarter, maybe a third of the booths were dedicated to couplers and connectors and tubes and fluids. I mean, it's more than I've ever seen. So definitely happening there. What else does this world look like then?
Yeah, so I mean, for immersion cooling, the largest market in the world is obviously cryptocurrency mining. You see them pulling down by the gigawatt, their power load. So it's hard for anyone to battle with that type of market size. Followed by that is obviously HPC, which you spoke to earlier. For us, the third one is honestly the government. We've had a massive pull from some of our government, contractors and things like that for a whole, suite of different purposes that obviously I can't talk to you guys too much about, but they're heavily drawing on that. Followed up by rendering and financial services, where obviously GPU intensive and then speed intensive. Also partnered with space constraints. Typically are about our top 5 business sectors, from blockchain down. So people that are either needing to do a whole lot with a whole little bit of space, or someone that needs to do something extremely, quickly. Those are the people that are really, drawn to us. And then obviously anyone that's using a, CPU or GPU over 300 watts typically starts to look at immersion cooling and seeing the benefits of the full bath immersion and all of that. So generally where our customers are at right now.
Huh, okay. So the second thing, and you've talked about it a couple times, that we saw is this two-phase immersion. And that system that we saw just had the one server in it, had the heat sinks removed, the tops of the CPUs were exposed to the fluid, and that one looked like it was boiling servers alive. Clearly it was cooling them, but the fluid is literally bubbling up as you see it through that one plexiglass window. A larger physical platform per U than the other single-phase solution. But just walk us through this two-phase. First of all, what does two-phase even mean?
Yeah, so two-phase fluid, two-phase cooling is the most efficient way to cool a computer. Generally, it takes a liquid form. It makes contact with a heat-generating component, turns itself into a vapor. That vapor is going to rise through the fluid, carrying the heat up to a condensing coil, which will have water running through. That cool water will pull the heat from the vapor. The vapor will turn itself back into fluid and drop down back into the tank. The reason why I say it's the most efficient is we're literally letting nature and gravity run its course. We don't have to pump this fluid or anything like that. It's generally cooling itself, but the only thing providing
all that bubbling action is just the natural cycle of its heating and cooling then.
Yes, sir. Yeah, we're generally taking heat off the chip using the bubbling, which is why it's so efficient, and carrying it up in that vapor form and then condensing it. So it's a fantastic way to cool computers, and it's extremely clean and extremely stable.
What's the difference in that fluid versus the oil in the single phase?
Yeah, single phase oil is a synthetic oil, just run of the mill synthetic oil. The two phase fluids are fluorinated hydrocarbons. It's a completely different blend of engineered fluid. They couldn't be any more different if they tried. Single phase fluid, like you said earlier, it drips, it comes out dirty, those types of things. On the two phase side, when you pull it out, it's completely bone dry, completely clean, like cleaner than when it left the factory, because these fluids are generally solvents, so they're helping clean pretty much the whole entire time the servers in the bath. It is a newer technology. It hasn't been around as long as single phase, but it absolutely has some massive performance benefits. And as we get into these upper echelons, 500, 600, 700, 800 watt CPUs, GPUs, things like that, it is my opinion two-phase cooling will absolutely take off and become the predominant, force within liquid immersion cooling for the industry.
I neglected to ask you, in the single-phase 48U rack, how many gallons of fluid is that?
That's about a 400-gallon tank.
And fully loaded, what does that weigh? Because the oil is heavier than water, I assume, isn't it?
Yeah, so that unit will weigh about 4,000 pounds fully deployed, depending. There's a pretty big variance of what servers people are going to put in there, but sure. I think for this, 4,000 pounds would be a safe answer for people to start investigating.
Okay, and do you have to replace the oil? Does some of it evaporate or burn off, or no? So as long as you don't spill it or have a leak of some sort, which I'm sure is a rarity, but
yeah, no, it does not boil off. It does not evaporate. Completely contained within the unit.
And same with the two-phase, you don't have to refill once you've got your level set on that thing?
As long as the system is properly designed, you will not have to refill the system. I mean, I'm sure a lot of the people listening to this, a lot of the users have heard about two-phase cooling and some of the evaporation issues that companies have had in the past. It's a very common thing. We told ourselves as a technology and immersion company, but I really like to clarify we're a sealing company. We're extremely good at sealing vapors and things. We have a number of patents on how we deal with the vapor when it expands and contracts and all those things. So as long as the system's designed well, you won't have to top it off, but the two-phase fluid absolutely does evaporate. And if it's not contained properly, it will drift off into the atmosphere.
And what's the cost delta between the oil and the two-phase? I assume the two-phase is much more expensive, but how does that factor into the overall cost of ownership of these systems?
Yeah, the two-phase fluid's about 10x the cost of a single-phase fluid, but you get increased efficiencies on the two-phase when it comes to your PUE and overall operating system of your whole entire data center, and that's the payback period, kind of delta there, and how people make their money back on two-phase. As the two-phase business expands, we are already seeing a number of new players come in to make two-phase fluids, which will drive those prices down, over time.
And who does that, like a 3M or somebody, any of these chemical engineering guys?
So publicly right now, 3M and Solvay are both producing two-phase fluids, and you can find them online. We're working with a number of other providers, behind the scenes that will soon make public announcements around their two-phase and single-phase offerings.
And can you mix them, or I mean, I guess you don't have to replace them much, but if you dropped in a gallon of someone else's, does that work or not?
Would it work? Sure. Would I recommend doing it? Absolutely not.
Okay.
One thing that when you operate the two-phase systems, that we operate them in a very clean, a very controlled manner. Some of the fluids have to have a real high level of filtration. So no, I would never recommend mixing either single-phase or two-phase fluids in any sort of way. Those things should be isolated, and systems should be ran on one type of fluid or another.
Okay. So the two-phase that we saw, describe that box. It's smaller in terms of its RACU footprint than your single phase, but it was the edge box, I think, that we were looking at. So talk through, like, structurally what you have there.
Yeah, so I believe what you saw was an EdgeBox 30. So it has 8 rack units, dissipates about 30 kW worth of heat. It's fluid agnostic across a number of different two-phase fluid providers. So if you wanted to put a 3M fluid or a Solvay fluid in there, it'll take generally all of those. They all have different boiling points, which is where people start to make the choices. Where do they want their systems to operate in with temperature range? So it's an eight rack unit system, dissipates 30 kW of heat. It's built for edge solutions and for labs and for people to get, like I said earlier, their feet wet with immersion cooling and start to work with their server providers on making them immersion ready and starting to understand that. But you basically have a tank body in which you put all the servers in. On the side of the tank body, we have a full control system. We also have a air-cooled rack, so you can put your switches and storage arrays and all that kind of stuff that you'd like to put in and either test or run at your edge site. And then we have a bellows box at the top, which is just a really basic way of controlling the vapor. When it turns on, vapor will expand, bellows will get bigger. When it turns off, the bellows will condense and take up that space, so we don't have a positive pressure event or a vacuum event, and make sure we don't have any leaks for our customers. So at a high level, that's generally what it is: a tank body, control system, air-cooled rack for people to put their own stuff in a way for us to control the vapor.
So how does the heat dissipation work in that system versus the single phase?
Same exact way. So instead of it being a plate heat exchanger, it's a condensing coil. I'm running water to that condensing coil, and then running water back out to a cooling tower or dry cooler, depending on the environment that we're in.
So when you're doing demos, like in an expo hall, you don't have access to everything you need, do you, to be able to run those things, or how does that work?
Yeah, over time, normally we have gotten access to most of those things. People are pretty reasonable about giving us power and water. The unit that you saw, the team probably adapted a dry cooler to, and we were running a dry cooler in that facility, actually inside of the unit. I wasn't at Dell World, unfortunately, so I'm kind of visualizing what you saw there.
So when we think about what orgs have to do to bring this into their data center, if you're going in a new opportunity, they haven't done liquid, what's the lift to be able to support either one of these solutions for someone that wants to try it?
I mean, for us, it's not a lot. We have a full MEP team on staff. So not only do we engineer the immersion systems ourselves, but we'll help you design the data center. So currently, right now, we have a number of full suite builds that we're doing for clients where we not only provide the tanks, firmware, software, all that kind of stuff, but we actually construct the building, get the cooling towers, transformers, all of that, and build full sites. So from our perspective, it's really not a heavy lift. We handle a lot of that lift for them. If not, it's just, engaging with a, an MEP contractor that they feel comfortable with, that we can share our spec sheets with, and, they go to design. But you got to remember, data centers are really one of the last things in the world that are air cooled, for large scale infrastructure. So it's really not abnormal when you go to someone who, develops infrastructure to say, hey, can we cool this with water? It's a, totally normal thing.
What's the scale at which point that effort pays back? I mean, it's got to be more than one rack, right?
We haven't had a client, deploy one rack or one rack. I've got people building everywhere from 500 kW to we've got a customer with a site so large I can't, say it here because people would know who it is. So yeah, no, it ranges all over the place. There's, as these chips, like as you talked about earlier, as these chips just gradually move to get hotter, we just see more and more interest from generally, everywhere, from people wanting to deploy a rack to the people wanting to deploy megawatts and megawatts. As these chips keep getting hotter, we keep finding new and newer, things that need solutions.
I think it'd be hard to argue that the SMB or even small enterprise needs this yet, but there may be a day. Do you see a vision for the technology to become smaller or easier to operationalize for smaller customers that may not have the data center investment that you're talking about with the some of your current larger customers?
Yeah, absolutely. I mean, once the servers are redesigned to be immersion ready, I can't even imagine how much smaller and how much more efficient we'll be able to make these systems. And then it would be generally an absolute no-brainer for anybody to do air cooling any longer. So I think that'll be the big switch as soon as we start getting immersion ready designs, immersion ready servers that are coming straight out of these OEMs, and people see the performance benefit. It won't take very long for people that are working in the cloud or doing other things to bring their data centers back and operate them, themselves, I think, too. So I think there's a lot of opportunity all over the board, and it all starts with, making these servers immersion ready. I mean, the results and the data that we're getting from our systems having to convert air-cooled servers over is outstanding, and it'll just continue to get better as the servers become more appropriate for the immersion.
Well, how can the OEMs do that? What's left on the table after they take out fans and optimize firmware? What else is left for them to do to be more immersion friendly?
I mean, the big thing is relaying out the board. So like, right now on a server, generally being super conservative, it's about 70% air, right? So removing that 70% of dead space would be a great start, because that's 70% less fluid that I've got to, use to fill up that space, on a really layman's term for people to think about it. And then, right now, the way that servers are designed are, here's the front of the box, and we're going to put something here, and we need to make sure the air flows over it, right? Well, with immersion, we don't need any of that, and the designers can go back and put the chips where they're most effective. You can double stack boards, you can build double-sided boards, you can do a whole lot of stuff to really shrink the footprint, put a whole lot of performance in a really small package, and keep things cooler than they are in air.
Well, you guys, this model is so ripe for the whole disaggregated movement that we're in now too. With, I mean, a lot of people are doing it. Fungible liquid. I mean, there's all sorts of people trying to take compute, DRAM in some cases, GPU resources and storage, and just put them in little pods, right? And then via software configure, how much of each one of those things you want. As I listened to you describe this sort of liquid cooled future, immersion cooled future, where it doesn't have to be a rectangle box that's a meter deep or whatever. It could be anything, and it really helps these guys that are looking at next gen infrastructures. I mean, that would give them a lot of creative space to play with, I think.
Yeah, I mean, like, you look at cryptocurrency miners, they're little boxes, little shoe boxes, people like to call them. They're in immersion. We're pushing over 7,000 watts through some of those boxes and cooling them fine. So looking at form factors that are that size with that much heat dissipation can really, in my opinion, change the way that we build computers and look at computers. Right now, everyone looks at computers as and generally a shelf, right? It's a pizza box put into a rack, and we haven't really stepped away from that. I think there's a lot of creativity that will come about once liquid immersion's more widely understood and more people are working on it. and we get out of the mindset of filling the racks with the pizza boxes.
Right. So the back to the two-phase that we saw, the edge box that was 8 RACU deep. Do you have, I assume you do, larger deployment options for two-phase?
Yeah, in
What?
the EdgeBox series, we have the EdgeBox 120. It's a 48U version of the compute core that you saw. And we have our Auto 120 unit, which is a fully robotic, the doors open up automatically. We have a robotic arm that can go in and retrieve the servers and swap them out. So yeah, we have both sets of options, the more manual edge boxes and the fully automated autos.
I think we need to see that. I want to see how that works because that
Yeah,
sounds really
absolutely.
cool. Can you, so with most data centers having height available to them, is there an opportunity for you to stack these systems at any point to take advantage of the vertical space?
Yeah, you could absolutely stack them, but a lot of the time, what customers find out is by having to put in forklift aisles and things to actually navigate to get the tanks in and out and run their site in a reasonable manner. That idea, it doesn't always double up, and a lot of the times when people lay out our tanks within their facilities, we can use way more power than they could ever get to us within the space, and they don't
Right.
really need to double stack.
Okay.
So that's really what we've ran into. Can you double stack them? Absolutely. Do you need to? Highly doubt it.
Okay. And what are the dynamics like? I talked before about the expense of power in Europe. Are you seeing geographical pockets? We talked about markets, but geographical pockets where this is more widely accepted and deployed versus others?
Yeah, luckily for us, the number one place of deployment and the number one draw is right here in Texas.
Dallas is the number one, or Texas
Not
the state?
Dallas, but Texas as a state.
What?
We have a lot
Why?
of our well, due to exactly what you said, the mining industry, right, was shut down in China, and a lot of them are coming to Texas because of the cheap power and the unique nature of the Texas power grid. And there's gigawatts and gigawatts of power going out in West Texas right now.
Huh, that's interesting. So the answer to the inefficiencies in power consumption of mining done with a more efficient power grid and also a cooling scenario that's efficient, then the cost metrics change on the effectiveness of mining. Then I suppose, huh?
Well, yeah, trying to run your miners out in West Texas and regular standard air cooling, or even with that, adiabatic walls or whatnot, in the middle of the summer doesn't really turn out too well for them, along with all the dust and everything like that. So their hands getting forced over to immersion cooling, which is fantastic for us. So we are seeing a really large draw of single phase out here in Texas. But to your point, yeah, there's a lot of interest in places like Asia where it's super humid and super hot, and they're very space constrained, need to build up rather than out into large plots of land. Um, and then the other one is just really inhospitable climates, is I guess what I would call it. Generally all around the world, working with our government partners, they tend to call us when something is not acceptable for air cooling, or they can't come up with a solution to make that work.
You probably can't talk about it much, but with government clients, I mean, one of the first things I think of are military applications, things like submarines or whatever, where they have tight spaces, limited capabilities. Um, some of these oil rigs and others where they just may not have the same access to power. I guess the submarine's got a reactor; it can do whatever it wants. But I mean, you still have some challenges there. I mean, I bet you find some pretty interesting use cases that perhaps you guys didn't even expect.
Oh, absolutely. Like you said, I can't really go into too much detail there, but if you go on our YouTube, you can definitely see some very unique public experiences that the military has put us in that we were allowed to film and share with our EdgeBox and our Black Pearl, which is our mobile supercomputer unit that is basically a truck with a supercomputer in the back of it. Yeah, we've definitely came across some stuff that I never thought in a million years that I'd be working on or getting to see, and it's been a really fun experience. But definitely do not want to share or breach their trust in any way.
Well, of the things that you can talk about, I mean, what's been inspirational for you in terms of what you're seeing, either how they're using it or what's coming out the back end or what's being enabled that they couldn't do otherwise.
I mean, I think the biggest thing for me is hearing feedbacks from the operators using the devices out in the field and getting to hear the feedback from them of the opportunities, to your point, that it allows them to do that they previously can't do. Can't really share what those opportunities are, but hearing from, in the field operators that they're using our technology and it's helping them do something that they previously couldn't do before is pretty much, the best thing that you could possibly hear. We have roughly, I think it's a little over 30% of our current employee force is ex-military. So we obviously have a whole, we really want to, do well there, supporting the troops, both, the employees that we have here and the troops out in the field that are using our technology.
So what's the starting engagement point look like for someone that wants to explore this with you in terms of finding out if full immersion is right for them? How do people get started and kind of self-qualify or come into your office? I assume you've got those things on display in Texas. What does it look like though?
I mean, I got to give a lot of credit to our customers. I mean, we don't really have to do an overwhelming amount of teaching, right? They come to us because they know they have a problem. They know that there's companies out there that have a solution, and most of the time, it's honestly them comparing us to other customers. I mean, other immersion deployment companies and things like that. Yeah, we've been really blessed to have some extremely intelligent customers that know exactly what they want, how to do it. And they've been very open to our expertise in immersion cooling and giving them some guidance on how to do it a little bit differently maybe than they thought. So most of the time it's a collaborative process between us and the customer, that does that. We have a lot of people coming to us with a problem rather than us having to go out looking for problems.
So you'll show up at some of these events like Dell Tech World, supercomputing type events and other things. And I said at the beginning, it must be absolutely miserable to move these things around. I know you're not the logistics guy, but just 400 gallons of fluid and the rack. I mean, just to get this stuff out there has got to be a task that you guys have gotten pretty good at sorting out how to do this in terms of these deployments too, huh?
Yeah, no, our deployment team is excellent. It's ran by a guy named Tim Tomlin, another ex-military guy. But yeah, no, we have it down. I mean, 400 gallons sounds like a lot, but it's just a tote. You know what I mean? It's one single tote going out.
Yeah, I want to see that guy pick up the tote and just haul that thing over the shoulder.
Yeah, we'll definitely be using a forklift or a pallet jack to move that kind of stuff around. But no, I mean, it's really simple. We have really nice crating systems for our units. So they just get put in a crate, they get put in the back of a truck and shipped just like anything else. The fluids that we use are not flammable. They don't have to get shipped on any sort of special routes or trucks or anything like that. So yeah, a lot of the times people see our setups and our units and stuff and think that it's overly complicated or large undertaking, but it's actually just a really simple process.
Well, I mean, that's why we wanted to have this conversation because I think there's so much excitement over what you guys are doing. Full immersion's not new, but it's every time somebody sees it, it's new to them for the first time, right? If they haven't been exposed to the concept. And most data centers, like we've been talking about, aren't exposed to it. They haven't had to. But with all of the push into AI and analytics and all of these things that are happening with GPUs, a lot of more organizations than historically will be engaging with GPUs because they just have to grow and continue to look for margin in their businesses. They're going to have to use these tools to get smarter about how they interact. So it does strike me as something that's going to become a bigger challenge, and not just in the HPC. I don't expect enterprise to be a massive segment for you guys in the next year, but it's going to be soon where this stuff is going to hit harder in these organizations. And if nothing else, at least understanding how these technologies work is pretty important for practitioners of any data center, really, just to know what's there, what's coming, and what's available.
Yeah, no, I couldn't agree more. I mean, I think this is a perfectly natural progression for computers to make the transition into liquid immersion cooling. Whether, which type of liquid immersion will end up being the end all be all is obviously still to be decided. But just with everything going on in the world, I cannot imagine a place in 5 years that will not have an abundance of, immersion cooling within the data center. So I could not agree more.
So we talked about what's next in terms of capabilities available or opportunities available to OEMs to design servers that are more ready for liquid. We talked about single phase, two phase. Is there a three phase? Is there some other thing after where you are, in terms of new technology coming? Like, where else can you guys go to innovate on these systems?
I mean, we can obviously, come up with lots of features and, different things to make the user experience a lot better. And I think we've done a really good job of incorporating a lot of those features into Auto, which is, the fully automatic one. But as far as cooling, no, there isn't a three phase. There isn't much beyond, two phase immersion cooling. Like I said earlier, I think two phase immersion cooling at the end of all of this and over the next 10 years will prove itself to be the go-to technology and the premier technology for liquid immersion, period. Just the way that it uses nature, its efficiencies, the cleanliness, the uniformness within the bath. I mean, just I could go on, and its ability to reject heat at insane rates. I truly believe that will be the technology for the future, and we have a whole runway to improve that and continue to make it better, and have all of these new fluid providers come in and start to create different fluids. And then we can do more and more on the boiler plates, which is how we pull the heat off the CPUs and all those types of things. Condensing coils can become smaller and more efficient. So I personally don't look past two phase. I think two phase is the end all be all. That is where I've dedicated 100% of my time since I've left school, is all on two phase immersion cooling, and single phase obviously now. But yeah, that is our three phase, four phase. It's two phase. Two phase is the future, and absolutely the way to go.
Well, just the fact that the server comes out dry, I think from a mentality of managing these things over years for practitioners will go a long way to help that being part of the bridge to get them there to say, okay, well, I can yank this and service it and it feels a little more comfortable. I don't have to do anything that's real weird, right? And like watch the oil run off the other one until it's ready to be serviced. I mean, it simplifies the process.
Yeah, and I'd encourage you to come out and work with some of these systems and check them out for yourself. A lot of people in the video were really overwhelmed on how you'd service them and work with them, and it'd be fun to do a video with you just to show you how simple it is, and why people don't need to be technically, I guess, easy way. They don't need to be afraid of it. It's really easy.
Yeah. Well, this is great. I appreciate the conversation. Like I said, the social media work we did around Dell Tech World. I mean, there were a couple videos that were extremely popular. You guys were very much a part of that effort, and so we appreciate that, and appreciate you coming on here, because there's a lot of events that we really like. We like going to OCP every now and then. We like going to Supercompute because it shows us what's coming in mainstream data center 2, 3, 4 years out sometimes, but it still is very much a preview of where these high-end workloads are going. So to be able to bring this, communicate this to a broader audience, I think will be great, and to help get people more comfortable with the idea, because regardless of whether or not you believe immersions is going to be a thing, I can assure you it is, because we go to all of these server vendor sites. I've seen the labs. I know what they're working on from what we see, and they're doing it. So they're taking this very, very seriously, and I'm excited to see what they do that's immersion specific. And I think there's a tremendous amount of potential there. So anyway, thanks for all the time today, the whole overview. Really appreciate it.
Yeah, thanks a lot for featuring our technology and giving me some time to come on and go a little bit more in depth on what we do. If anybody has questions, feel free to send me an email. My email is public on our tmgcore.com website. Would love to do some education on immersion cooling and spread the technology that we're working on.
Got it. And I'll be down for ribs and robots sometime soon.
Yeah, there's a place called Heart 8 right down the street. We'd love to take you. So we'll see you.
Fantastic. I can be there shortly. All right. Thanks again for doing this.
Yeah, thanks.